Hello everyone. Welcome to the Cracking the Most Complicated Concepts of A-Level Physics Unit 4 video. This is going to be a very advanced lecture. So I asked some of my students who had the best preparation over the months throughout the length of the course that which questions did you find the most problem seen? And they gave me a list, and I made this video based off of those questions, because if my students face the problems, it's very likely that students all around the world would face problems in these concepts as well. So very unlikely that exactly these questions will appear in your exam, but this will just set your mindset of how to tackle questions like this in your upcoming exam. So I won't be discussing the most repeated questions and frequently asked questions in this video, because all of these are compiled in a frequently asked question and answer sheet, and the PDF link is given in the description. You'll find all the most common questions of Unit 4 in that PDF. This will be extremely useful for your exam. Now, like I said, I won't be discussing the most basic concepts here, but if you want to revise those ones as well, I would highly recommend you to look at the Unit 4 full syllabus revision video, and the link is given in the description. Let's look at the very first question. This is not the most complicated one, but it requires you to have some ideas about the standard model. So let's see what the question says. A positron and a muon travel at the same speed through a magnetic field. The magnetic field is directed into the page. So this information is given. Which of the following diagrams best represent the motion of the particles? Right. So you need to understand the structure of a positron and a muon. A positron is an antiparticle of an electron, which belongs in the first generation, but muon belongs in the second generation. And you should know by now that second generation particles are heavier. So muon has a greater mass. So even though it has the same speed, since its mass is greater, it has a greater momentum. And momentum of a charged particle in a magnetic field is related by the equation P equals V Q R. Since a muon, since it belongs in the second generation, has a greater mass, it has a greater momentum. So they have the same charge and they're in the same magnetic field. So since momentum is greater, its radius of curvature would be greater. So it should have a greater radius of curvature. But for option A, it shows it has a smaller radius of curvature. So A cannot be the answer. Um, Muon has a smaller radius of curvature in option D. So this cannot be the answer either. So my answer is between B and C. To determine, because B and C both shows a greater radius of curvature, but both cannot be the answer. So this is where you have to bring in the concept of Fleming's left-hand rule. So a positron is a positively charged particle, and you should remember the direction of motion of a positively charged particle is the same as direction of current. So current is upward for the positron. Magnetic field is into the page. This is B. So the positron should curve to the left. But in option B, it shows the positron is curving to the right. So B cannot be the answer. Answer should be C. All these for just 1 mark. And I always tell my students, always start with section B, because there will be some really complicated questions in section A that you might lose a lot of time answering. So it's always a good idea to start with section B. And once you're done with section B, then and only then you move on to section A. The next question is from October 21, question 5. It's very interesting and intellectually challenging. Let's see what the question says. The diagram shows a rectangular coil of n turns. The coil rotates around an axis as shown. A magnetic field acts perpendicular to the plane of the coil in the position shown. Fine. The magnetic flux linkage with the coil is n phi. The coil is rotated through an angle of pi radians. Pi radians is basically 180 degrees. This will come in handy. Which of the following is equal to the change in magnetic flux linkage with the coil? So it's very difficult for me to explain it just by this diagram. So what I've done is I have taken a picture out of my lecture sheet and placed it in the second slide. So this is the coil, by the way. This is the coil. Right? And this, the blue arrowed lines are the magnetic field lines. So over here, the coil is perpendicular to the magnetic field. So it rotates through 90 degree here and 180 degree. So check this out. Initially, this is n phi magnetic flux linkage, right? Magnetic flux linkage, it's n phi. And this piece of information is given in the question, n phi. But when it rotates through 180 degree, check this out, is the same value of flux linkage but negative. So this should be minus n phi. So after the coil rotates through 180 degree, the flux linkage is negative, same value but negative. But the question says, which of the following is equal to the change in flux linkage? So initial flux linkage is n phi and final flux linkage is minus n phi. So change, how do you find out the change? You subtract minus n phi. That makes it twice n phi. So this is the change in flux linkage. So answer should be D. When I looked at this question from October 21, question 10, it reminded me of a quote from Sherlock Holmes. He said, "Intuitions are not to be ignored. They represent data processed too fast for the conscious mind to comprehend." And I'll tell you why this reminded me of this quote. Because the moment I looked at this question, I knew intuitively answer is B. And then that was my subconscious mind making the decision for me. And then let me walk you through the process of how I have to explain to you, because I cannot tell you about my intuition and expect you to trust my instincts, right? So, you know from your IGCSEs, a wire which is parallel to the magnetic field has zero force or minimum force acting on it. But the wire carrying current, when it is perpendicular to the magnetic field, the force is maximum, right? So, the question says, which of the following graphs show how the force F on the wire varies as theta is increased from 0 to 90 degrees? So let me show you this way. So initially, sorry. Initially, the wire was like this, 0 degree, but then it increased to 90 degree. Initially, it was parallel, but then it became perpendicular, right? So the question says how the force F on the wire varies. So of course, initially when it is parallel, force is 0, and when it became 90 degree, the force became F, as in the maximum force. But you have to bring in the mathematical aspect of it. A wire carrying current in a magnetic field is given by F equals BIL. But you know what? This is not the actual equation. No, this equation only applies when the current is perpendicular to the magnetic field. But what is the generic equation? Generic equation is BIL sine theta. And this is why it has to follow. If you keep on rotating, the force would vary like a sine curve or sinusoidally. So it should look like this. So you have just a quarter of this. So since it's sine theta, answer has to be B, because you cannot turn this into a sine graph. And C looks promising, I get it. But C cannot be the answer, I'll tell you why. C cannot be the answer because um, initially it says at 0 degree force is maximum, but you know at 0 degree force is minimum. So C cannot be the answer. If you had started with 90 degree, then C would have been my answer. So you are left with B, because A and D, you cannot turn this into sine graphs. Right. So when I saw this question, as in October 21, question 14, I was a bit disappointed. Full disclosure. Because the way I taught my students, they should know by now that when a question asks you about current time graph, right? It's always exponential decay, whether it's a charging graph or whether it's a discharging graph. So I was a bit disappointed. But then when I looked at this question, I was actually very impressed that they could figure out that this is actually a problematic question because it is not a standard uh, exponential decay curve like this one. I'll come back to this question, but let's look at this one from October 22, question 12a. When the capacitor is completely discharged, the two-way switch is moved to position S1. So check this out. When you move it to position S1, this is a charging circuit. And when you move it to position S2, this is a discharging circuit. And you know what, everyone? If you were to ask, if the question were to ask you, what would the current time graph look like when the switch is moved to position S1 or S2? The shape of the graph would have been the same. The values might have been different, but the shape would be the same because the current time graph is always the shape of an exponential decay curve, whether it's for a charging circuit or a discharging circuit. Always, no exception, right? So this is why I was a bit disappointed when I saw some of my students asking me that they have problems with this question. This is not as simple as it seems because let's see the question. The switch is closed at time t equals 0 and opened at t equals to 20 seconds, right? Sketch a graph on the axis below to show how the current I through the resistor varies with t. So I was thinking, how exactly am I going to explain this? And then I realized I have a simulator and you have a very somewhat of an identical circuit. So initially when the switch is closed, you can clearly see that the current is 0. But the moment you close the switch, check this out, current drastically rises to a maximum value and then stays constant. Check this out. This part is very important. Current stays constant. The capacitor charges up instantly, but the current stays constant. But the moment you open the switch, check this out, this charged capacitor will now discharge through this resistor. So initially, when the switch is closed, the current stays constant, but when the switch is opened, the current exponentially decreases. This simulator doesn't show the exponential part, decreases and drops to 0. So exactly what you have to do over here. Initially, the current stays constant up to 20 seconds, and then when you open the switch, it exponentially decreases. But over here, this is a different concept. This is a charging and discharging together. When you move it to S1, it is a charging circuit, and when you move it to S2, it becomes a discharging circuit. So at any given time, the current will never remain constant. So here you have to mark the values. When it's moved to S1, the PD is 5000 and the resistance is 65 kilo ohm. And to find the initial current, always use the equation V equals IR. Plug in the values. V would be 5000, R would be 65,000. Of course, you have to convert it to ohm, and you find out I. Then comes the most interesting part. You have to mark, because it's a 4-mark question, right? You have to mark the value of the total time for charging here as well. So always remember, the total time of charging or discharging is always given by 5RC. So total time equals 5RC. So R is 65,000 and C is 34 microfarad. Let's see what the value gives me. So the value is around 11 seconds. 5RC gives you 11 seconds. Always remember, when a capacitor charges up or discharges to the resistor, the total time of charging or discharging is always 5RC. And of course, you have to mark the value of current here as well using V equals IR. Next question is also very interesting. Question 17b from October 23. A copper rod PQ is moved with a velocity V along a pair of copper rails as shown. The rails are a distance d apart. Fine. Okay, so I really hope you know by now that crosses represent a magnetic field into the page. Crosses represent a magnetic field into the page, right? So when you move this copper rod through this magnetic field, the rod will cut the magnetic field lines. There will be a change in magnetic flux linkage with the copper rod. And whenever there is a cutting of magnetic field lines, an EMF is induced. Now, this EMF drives a current through this copper rod. And according to Lenz's law, this current produces a magnetic field so that it opposes the change that is causing it. So what was the change that was causing this current? It was the movement of this rod to the left, right? So there has to be a force opposing the movement. So the force, magnetic force on the copper rod would be to the right, in the opposite direction to the motion. There is a magnetic field into the page. There is a force to the right. So what is the direction of current? Can you guess? What do you use to find this out? Of course, Fleming's left-hand rule. So magnetic field is into the page. The force, the thumb represents the force, is to the right. So the current is from P to Q. This is current. And if the current is from P to Q, the EMF should also be from P to Q. And everything was based on Lenz's law here. This is also a very interesting question. From May 24, question 13b. The student places the disc on a horizontal turntable and places the coin on the disc, as shown below. The mass of the coin was 8.8 gram. The diameter of the disc was 30 centimeter. Fine. The disc rotated at 45 revolutions per minute. Calculate the angular velocity. This is one of the most common questions, part A. So the students did not have problems with part 1. Most of the students had problems with part 2. So let's first figure out part 1. because I'll be needing this value in the second part, right? So 45 revolutions per minute. So you can work this way, per minute as in 60 seconds. In 60 seconds, it undergoes 45 revolution. So in 1 second, it should be 45 divided by 60. So 45 by 60 is 0.7, and whatever happens in 1 second, you call that the frequency. So it should be 0.75 hertz. Next, the equation for angular velocity is omega equals 2 pi by t, or in terms of frequency, it becomes 2 pi f. So omega is 2 pi into 0.75 times 2. So the value is 4.71 radian per second. 4.71 radian per second. Right. Now the next part of the question says, when the student placed the coin near the center of the disk, the coin remained in position and rotated with the disk. When the student placed the coin at the edge of the disk, the coin slid off the rotating disk. The student estimated that the closest the coin could be to the edge of the disk without sliding off was about 5 centimeters. Deduce whether this was suitable. You should assume that the maximum friction force is 0.02 Newton. So guys, why is it that when the coin is placed near the center, it stays at the center, but when it is moved towards the edge, it slides off? Because when you move away from the center, you require a greater centripetal force. So the equation is Fc equals mr omega squared. So the whole thing is rotated at a constant RPM. So omega is constant. So as you move away from the center, R increases. And the required centripetal force also increases. But this is the issue. The centripetal force is provided by the frictional force, which has a maximum value. The moment the required centripetal force exceeds the frictional force, it cannot stay at the circle anymore, or it cannot maintain the circular path anymore. It slides off, right? Because the necessary centripetal force is now greater than the frictional force. So friction cannot provide the necessary amount of centripetal force that is needed to keep this in circular motion, right? So what do you have to do? You just plug in the values. Since frictional force will be providing the necessary centripetal force, so the centripetal force corresponding to the maximum moment of friction is 0.02. This is 0.02 equals the mass of the coin is 88 gram. So 8.8. 8.8 times 10 to the power minus 3. R is, this is what you have to find out, the R, times omega square, 4.71 whole square. So R, as in, this is R. Okay, so R would be, so if you plug in the values in your calculator, R becomes 0.102 meter, or multiply it with 10, that becomes 10.2 centimeter. But that's not what the question asked you to find out. The question asked you to find out, the student estimated the closest the coin could be to the edge of the disk. So this is the distance that the question is asking you to find out. So you know the radius. Since the diameter is given, the radius would be 15 centimeter, right? If the diameter is 30 centimeters, the radius is 15. So 15 minus R gives you this distance that it can be from the edge, right? So 15 minus 10.2. So distance from edge would be 15 minus 10.2, and the value that you get is 4.8 centimeter, which is about 5 centimeter, and it also matches with the mark scheme. So for the next question, we'll be looking at May 24, question 17. Scientists are developing safe methods for removing old satellites from orbits. Some scientists plan to use electrostatic force. A spacecraft will fire a beam of electrons at a satellite. This will give the satellite a negative charge and the spacecraft a positive charge. There will be an electrostatic force of attraction between the satellite and the spacecraft. The spacecraft will then move away, taking the satellite with it. Fine. The diagram shows the electric field around the spacecraft X and the satellite Y. So X is the spacecraft and Y is the satellite. When they have equal and opposite charge, this is very important. Equal and opposite charge. So this forms somewhat of an electric dipole. Add dashed lines to the electric field to show the equipotentials at intervals of equal potential difference. Right. So for part 1, they ask you to draw lines of equipotential. Always remember, equipotential lines are always perpendicular to the field lines. So the lines that you see in the electric dipole are the field lines. Always remember, the equipotential lines must be perpendicular. And always remember, equipotential lines must be drawn with dashed lines or dotted lines. So this is what your equipotential lines look like. And you can check that somewhat it looks perpendicular to the fill lines. You don't have to draw so many, I just copied it from the mark scheme. Next, label the equipotential that represents 0 volt. So 0 volt has to be over here. The middle line represents 0 volt. I'll tell you why. This is the spacecraft and this is the satellite, right? Spacecraft is X, satellite is Y. So spacecraft gets a positive charge and satellite gets a negative charge. Let's talk about electric potential, right? So this 0 volt is actually the electric potential. Always remember, electric potential is a scalar quantity. So over here, you have to find out the resultant electric potential due to X and due to Y. So the equation for resultant, the equation for electric potential is, if I want to find out for Vx, it should be kq by r at this distance, right? And if I want to find it for Vy, it should be minus kq by r, because the charge determines the value of the electric potential. It's a scalar quantity, but the minus sign does not represent the direction. The minus sign represents whether it's positive or negative. It's not the direction. And if you want to find out the resultant, Vr, you just have to add these up. Vx plus Vy. They have the same values, but one is positive, the other one is negative. So what you are left with is 0. Since R is the same midway. Part B is also quite interesting, and it is based off the concept of electric potential. After some time, the charge on the spacecraft will be plus 1.5 times 10 to the power minus 6 coulomb, and the charge on the satellite will be minus 1.5 times 10 to the power minus 6 coulomb. Calculate the minimum energy in joules required for an electron leaving the surface of the spacecraft to reach the surface of the satellite. You are dealing with an electron, right? And why would it require a minimum energy? It has to do a work, right? It has to do a work against the electric field, right? There has to be a work done. Assume that charge on each object does not affect the potential at the surface of the other object. Radius of satellite is 2.5 meter. Radius of spacecraft is 2.5 meter. Now, it is moving from surface of the spacecraft to the satellite. Okay, from here to here. And you have to focus on the word surface as well, right? So what is the electric potential at the surface of the spacecraft? And what is the electric potential at the surface of the satellite? So for this, you find out V for this one equals KQ by R, and this is the R, radius of the satellite. So the value for V for spacecraft, just plug in the values. You know the value of K, 8.99 times 10 to the power 9. You know the value of Q. Spacecraft has a positive charge. So Q would be plus 1.5 times 10 to the power minus 6, and R would be 2.5 because I want to find out the electric potential at the surface. So the value of electric potential at the surface of the spacecraft would be, so value for the electric potential at the surface of the spacecraft is 5394 volt, and you do the same thing for the satellite, but the charge on the satellite is minus. So electric potential at the surface of the satellite is the same value, but because the charge is negative, the electric potential will also be negative, minus 5394. Right, 3, this will be 4, right, volt. Now, let's recall some basics. You know the equation for electric potential, right? So electric potential, one equation is KQ by R, the other one is electric potential energy per unit charge, right? But if you want to find the change in electric potential, that would be change in electric potential energy per unit charge. And guess what? So this is the change in electric potential energy that corresponds to the work done. In other words, the minimum energy required, right? So change in electric potential energy is equal to work done equals to change in electric potential times the charge. So the work done, or in other words, the minimum energy required would be the change in electric potential. So 5394 minus 5394. So 5394 minus 5394 gives you 10788. 10788 times Q is the charge of an electron, which is 1.6 times 10 to the power minus 19. So the work done is 1.6 times 10 to the power minus 19 gives you 1.7 times 10 to the power minus 15 joule, which also matches with the bar scale. So guys, like I said, we were just discussing the most complicated ones. For the basic revision, please check out the full syllabus revision video. The link is given in the description. And I have compiled literally all the important questions along with the answers up to Jan 2025 in the PDF. That will be very useful. Thanks for watching and good luck with your exam.